Hello and welcome again. Let us start with the second lecture of the unit interfacing with parallel port, and in this we'll be studying how to interface the opto isolators with 8051. Now, basically, what is an opto isolator? Opto isolator, which is also called as an optocoupler, photocoupler or optical isolator, is an electronic component which transfers electrical signal between two isolated circuits by optical link by the way of light. The optoisolators prevent high voltages from affecting the system receiving the signal. Normally, the optoisolators withstand the input-output voltages up to 10 kilovolts, that is called as the isolation voltage of the optocoupler, and the voltage transients with speeds up to 25 kilovolts per microsecond. So they can save the circuitry from these high voltages and high voltage transients. A common type of an opto isolator is the LED at the input side and phototransistor at the output side, and these are available in the same pack. The other types of the opto isolators include LED photodiode combination, LED LASCR combination, or the lamp and photoresistor pairs. Usually they are used to transfer digital signals which are in either 0 or 1 format, but in some cases you can also transmit the analog signals. Now, why opto isolators are used? Electronic equipment and the signal and power transmission lines, these are always subjected to voltage surges which are induced by the lightning, electrostatic discharge, radio frequency transmissions, then switching spikes or pulses. So these are the different ways in which the high frequency transients or surges are induced. In remote lightning strikes, these induce surges up to 10 kilovolts and 1000 times more than the voltage limit of the electronic component. Normal the voltage rating of the electronic components is maybe 1 kilovolt, 100 volts, 50 volts. So these 10 kilovolts are quite higher than the normal voltage rating of the devices. Now, circuit can also incorporate high voltage by designs, in which case it needs safe, reliable means of interfacing its high voltage components with low voltage components. Maybe let us take an example of a power circuitry, power electronic circuitry. Now there are two parts of any power circuitry. One part is the power electronic converter, which will convert the high power in one form to the other form. But this high power circuitry is controlled by a very low power circuitry, maybe a microcontroller circuitry. So the microcontroller works on 5 volts, and let us say we are controlling hundreds of megawatts of power. Then how to interface these circuits? So in this case, the opto isolator comes in picture, and the main function of the opto isolator is to block these high voltages and the voltage transients, so that the surge in one part of the system will not disturb the other part. Basically, the same function which is done by the opto isolator can also be done by isolation transformer, which use inductive coupling between the galvanically isolated the input and output sides. So basically, the opto isolator as well as the isolation transformer, they are used to provide galvanic isolation between the input and the output side. The meaning is that the grounds are totally separate. There is no physical connection between the input side and the output side. They are either magnetically coupled when we are using the isolation transformer, or they are optically coupled when we are using the optocouplers. Now, what are the specifications of an optocoupler? Basically, the most important specification of the optocoupler is the isolation voltage. How much voltage it can withstand, how much voltage it can isolate. So the allowable maximum alternating voltage that can be applied between the input and the output pins of the optocoupler, and which is expressed in the RMS value, is the isolation voltage. Then if the input side is LED, then the forward current of LED is also an important specification. Then the reverse voltage that can be applied to the LED is another specification. LED power dissipation is the fourth one. Then if at the output side we have a photo transistor, then the power dissipation of it is also a specification. Now the most important specification for an optocoupler is the current transfer ratio, which is also abbreviated as CTR, and it is expressed in percentage. So the CTR is equal to 100 into IC divided by IF. IC is the collector current, IF is the forward current of the LED. So how much amount of current amplification is available using this optocoupler is the measure, and that is expressed in the CTR. Then the propagation delay time is also one of the important specifications. So when a pulse is applied at the input side, after how much time it will be available at the output side. So the TP in microseconds is the propagation delay time. These are a few packages of the Opto Isolator. In the first case, when it is IL74, we have only one optical pair, one LED and one photo transistor. Then in the second case, it is ILD74, there are two pairs, and in ILQ74, there are four Opto isolators present in the same pack. Now, how these Opto isolators are used with 8051? So the output of the 8051, the pin of any port which is configured as output pin, in this case it is port 1.0, is connected to the LED of the Opto isolator. In this case, the low signal at pin 1.0 will activate this circuitry, because the anode is connected to the positive 5 volt supply, and when this pin will be 0, that time the LED will conduct, it will emit light, and the light will be incident on the base of the photo transistor, and it will conduct, and as it conducts, the 12 volt supply will get connected to the lamp, and the lamp will glow. So when this P1.0 will be low, that time the lamp will glow. So this is how the optocouplers are used to interface the microcontroller with high power devices. In this case, the ground of this plus 5 volt supply, which is also the same as the ground of the 8051 power supply, and the ground of this plus 12 volt supply, which is powering the lamp, are isolated. There is no connection between these two. So these two are not shorted. So these are isolation. Now let us consider one more simple standard interfacing circuitry in which we are using a power Mosfet instead of a transistor. In the previous lecture we studied the transistorized circuits. So in this case the transistor is replaced by the power Mosfet. Otherwise the functioning of the circuitry is almost the same. So instead of the Darlington pair we can use a power Mosfet. In this case IRF 530 is used as the power MOSFET. It is normally used. International Rectifier is the manufacturer of this transistor. So output of the microcontroller is connected here. The advantage of the MOSFET is that it requires minimum current to turn on. So only a voltage level is sufficient to turn on the MOSFET. So you need not require any current boosting, current amplification circuitry as we did in the transistorized case. We use the Darlington pair. In this case, a simple transistor, a MOSFET, is sufficient to provide that much amount of current. This is all for the lecture. Thank you.